Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of What to Look For in the Night Sky, talking about the week of March 4th, 2024. This time around, we're headed into spring. So as we head into spring, we'll do something interesting, right? We have certain stars that we associate with spring because they're high up in the sky as it gets dark. They're up for most of the evening when people would be out observing the sky. We think of those as spring stars. Yeah, there they are. We're going to ignore those stars. And we're going to look at stars that we normally associate with summer and fall, late fall maybe, to say, well, these are the ones that are disappearing in the west in the evening and the ones that are rising in the east in the morning. And part of the reason we're going to do that is because we've got planets and the moon attracting our attention in those directions. And so let's start right now. So on the evening of the 4th into the 5th, and all of these are really the mornings, because we talked about last week what time of night different phases of the moon are visible. And what we figured out was that, you know, as the moon wanes away, it's up in the morning sky after midnight. And so we're talking about after midnight for all of these, because the moon starts about 1/3 full in the morning of the 5th, and it gets less full. So we've got a nice dark sky this week. And it's going to start in the morning of the 5th. It's about 1/3 full. So a good time to get out and see it is probably 3 in the morning or 4 in the morning maybe. And it's going to be sitting, nestled in a little cup of 3 globular star clusters. And we've talked about these kinds of star clusters a lot. These are some of the most interesting things for us to see. We live in a galaxy. The side view of the galaxy, we draw a schematic that looks like that. It says we live out here. And if we look toward the center of the galaxy, which is in the region of Sagittarius and Scorpius, we see lots of globular star clusters scattered in a halo around the center. So we have to look to the center to see those, as opposed to open star clusters that are all along the disk of the galaxy here that we can see all the way through there in that flattened plane of the galaxy. So these globular star clusters, several 100,000 stars, all bound together, gravitationally bound. And so there's so many stars, and they're pretty far away from us out here in this halo around the center of the galaxy. It's hard for us to distinguish individual stars, so we see them as a blur of stars. But in the direction of the center of the galaxy, they're everywhere, and it's a lot of fun to look for them. And that's really emphasized in this morning, where you have this sort of cup of 3 of them sitting about 3 degrees below the moon. So if you have the moon there, you might be able to see these with your binoculars. You probably could be better off scanning that area with a small telescope. And the moon, a 3rd full moon, isn't terribly bright, but it's bright enough it's going to wash these things out a little bit, being so close to these. But see if you can find M69, M54, and M70, these globular star clusters that sit there. Now, the next morning, the moon will have moved off to the east. That's what it does every day. And so it will have moved off in the east relative to the stars, and it'll be sitting about 3 degrees again above another globular star cluster. But now it's down 20% full. So it's getting fainter and fainter and fainter. And so we should have a little trouble finding M55. Again, use your binoculars, use a small telescope, see if you can find this globular star cluster. And we have another globular star cluster. It's near the next morning, on the morning of the 7th. But this one, we've got this globular star cluster, M75, is now about 8.5 degrees away from the moon. The moon's down a beautiful crescent. So if nothing else, you get outside and you see a beautiful crescent moon. And the moon, so it's down to this about 12% full, about 8.5 degrees from M75, but just about 2 degrees from M75, right on a line with the moon, is Pluto. And if you've never had a chance to see Pluto, maybe this is an opportunity, but you need a pretty big telescope to do it, right? I don't think you want to even try unless you've got a 14-inch diameter telescope to look for that thing. And then when you see it, you're going to have a hard time noticing that's what it is, because there's just going to be a whole bunch of stars right there. Your best bet, and you can do it with a much smaller telescope, your best bet is to take a smaller telescope and a camera. If you've got a digital camera, a CCD camera, you can shoot through your telescope. Try this on 2 or 3 consecutive nights. Find M75 and then scan down a couple of degrees from M75 and shoot on consecutive nights to see if you can see something that's moving in that region. And that's likely to be Pluto that's moving there. So it's an opportunity to check out Pluto because it's aligned with the moon and M75 on this night. Find M75 and know that Pluto for the near future is going to be just a couple degrees south and maybe east of M75. And so that's the region you want to scan to be seeing if you can find Pluto. Fun little activity. Now, That's all in the morning sky. In the evenings this week, we've got Jupiter. And so Jupiter, we're losing Jupiter. It's getting further and further and further west each evening. We've enjoyed Jupiter as a big bright object in the evening sky as we head into spring. So these stars, we said this, right? This region right here, all of these globular star clusters are in a part of the sky that we associate more with summertime observing than with early spring observing like this. And this is a region we associate more with fall into winter observing because we're above Cetus, the sea monster right here. That's where Jupiter is sitting. It's right above Cetus. And it's about 4 2/3 degrees. You go out, Jupiter's the biggest, brightest thing in the southwest in the evening sky. If you're in the north like I am, it's the southwest in the evening sky. You'll see Jupiter sitting about 4 2/3 degrees above the star Mu Ceti. So it's the Mu star in the constellation Cetus, and it's about a 4.3 magnitude star. Gamma Ceti is another 7 degrees or so down from there. So you go from Jupiter to Gamma Ceti is the next brighter star above the background back there at about 3.5 magnitude. And you drop another 3 degrees down to Delta Ceti, and Delta Ceti is a 4th magnitude star. So these are all stars you can see with your naked eye. These are all stars you don't need aid. As long as you've got a fairly dark sky, you don't need binoculars or something to see them. But they're not bright. These aren't stars that are jumping out of the sky at you. And this whole region of the sky sets by about 10 p.m. So for me, local time, 10 p.m. And so right after dark, I want to get out there. As soon as it's dark enough to do this observing, because I'm going to be losing it. And so let the glow of the sunset dissipate. But just immediately, when that's done, this is a good time to be out here checking this out. And so we drop down to Delta Ceti, and within a degree of Delta Ceti, back off to the east of Delta Ceti, a degree is M77, a galaxy like our own Milky Way galaxy. We look at our Milky Way galaxy, that's our side view schematic. Our top view looks something like that, maybe, I don't know. So we've got a galaxy. This is our galaxy tipped up this way. This is the galaxy tipped that way. This is an external galaxy, an external spiral galaxy. It's a big, beautiful one. See if you can find it. It's so close to Delta Ceti that it's one of those, it's pretty faint. You're going to need a telescope to do this. And you definitely don't want to wait. You can't let it get too close to the horizon. And you got to wait for the glow of sunset to disappear. So this is you got a little narrow window in there in order to see this thing right now. But it's a good chance to see it as we look at it disappearing and using Jupiter as a guide to hop to these stars and get there. This is it. We talked about this a few times before. We love this galaxy. We absolutely love this galaxy. If you go back 110 years, Vesto Slipher was measuring the spectra of galaxies. We didn't know these were galaxies at that time. So he was measuring spectra of spiral nebulae. And these spiral nebulae, he found some of them to be moving away from us at enormous speeds. And so we start to measure the redshifts. That leads us to a model of the expansion of the universe, all of these galaxies being pushed away from all the other galaxies by the expansion of the space between them. And so this is what's going on. This is one of the first 2 galaxies he measured a spectrum for and got a significant redshift for to start to understand the expanding universe. So we really love the historical aspects associated with this galaxy. This is what we got for you this week. Get out there, see if you can watch the moon fading away in the morning sky. Use it as a guide to a bunch of globular star clusters. And if you're really ambitious, see if you can find Pluto in the morning sky. And then in the evening sky, use Jupiter as a guide to find a few stars in Cetus. And if you're ambitious, see if you can find the galaxy M77. And it should be a good week. As always, thanks for watching, everybody.